June 1982, the Falkland Islands. British paras are advancing across frozen, wind-blasted terrain toward Argentine positions on Mount Longdon. The weapons in their hands are not some cutting-edge 1980s technology. The L7 general-purpose machine gun. They carry fires using an operating mechanism designed in 1942. The Browning .50 caliber heavy machine guns defending Argentine bunkers date back even further, to a prototype John Moses Browning test-fired in October 1918. The First World War had not yet ended. 40 years of supposed military advancement and the weapons tearing men apart in the South Atlantic were fundamentally unchanged from their World War II ancestors. This was not military backwardness. This was proof that certain engineering solutions are so correct, so perfectly matched to the physics of automatic fire, that replacement programs have repeatedly struggled to improve upon them. The L7 GPMG, known to British soldiers as the Gimpy, represents one of the most successful hybrid weapon designs ever created. Belgian engineer Ernest Verviers completed it in 1953 at Fabrique Nationale Herstal. His genius was recognizing that two World War II mechanisms designed by enemies could be combined into something superior to either. The locking system came from John Browning's M1918 BAR, the Browning automatic rifle. Verviers took the BAR's vertically tilting locking lever, inverted it, and reconfigured it as a downward locking lever connected to the bolt carrier through an articulated joint. FN had manufactured the BAR under license for decades, giving Verviers' team intimate knowledge of Browning's action. The feed mechanism came from Germany. The MG-42, the weapon Allied soldiers called Hitler's buzzsaw, contributed its belt feed system, trigger mechanism, quick-change barrel concept, and ejection port dust cover. Combining American reliability with German feed efficiency created a weapon that entered Swedish service as the KSP-58 in 1958. Britain adopted it as the L7A1 in 1961, following competitive trials against the American M60 in 1957. The L7 replaced two separate World War II-era weapons, the Vickers medium machine gun and the Bren light machine gun, consolidating both functions into a single platform. This was itself vindication of the German Einheits Maschinengewehr concept, the universal machine gun pioneered by the MG-34 in 1934. By the Falklands, British forces carried the L7A2, an improved variant introduced in the late 1960s. It featured a 10-position gas regulator, up from 3, a polymer buttstock, refined feed pawls, hammer-forged barrels, and provision for a 50-round belt box. None of these modifications touched the fundamental operating cycle. The gas-operated long-stroke piston system, the BAR-derived tilting locking lever, the MG-42-derived PAL-type feed architecture, all remained mechanically identical to their World War II predecessors. The specifications tell the story. The L7A2 fires 7.62 by 51mm NATO ammunition at a cyclic rate between 650 and 1,000 rounds per minute. Muzzle velocity reaches 840 meters per second, approximately 2,756 feet per second. Effective range extends to 800 meters from the bipod, 1,800 meters from the L4 tripod in the sustained fire roll. The weapon weighs approximately 11 kilograms, just under 24 pounds, with a barrel length of 630 millimeters. The feed mechanism deserves particular attention. The MG-42's PAL-type feed system pulls the belt from left to right across the top of the receiver. Two feed pawls, upper and lower, alternate in their grip on the belt, creating a smooth, positive feed action that virtually eliminates jams from belt misalignment. This system proved so effective that it has been copied by nearly every belt-fed machine gun designed since 1945. The quick-change barrel system, also derived from the MG-42, allows a trained gunner to swap a hot barrel in under 10 seconds, critical for sustained fire operations where barrels can reach temperatures exceeding 400 degrees Celsius. The gas system operates on the long-stroke piston principle. Propellant gases are tapped from the barrel through a gas port and directed into a cylinder beneath the barrel. This gas pressure drives a piston rearward, which is connected directly to the bolt carrier. The carrier moves rearward, camming the locking lever out of engagement with the receiver, unlocking the bolt. The entire bolt group then continues rearward, extracting and ejecting the spent case while the feed mechanism advances the next round. Springs drive the system forward, stripping the new round from the belt, chambering it, and locking the bolt. This cycle repeats as long as the trigger is held and ammunition remains. The Browning M2's lineage runs even deeper. General Pershing requested a scaled-up heavy machine gun in July 1917. German armoured aircraft like the Junkers J-1 were shrugging off .303 rifle caliber fire. Browning, already responsible for the M1917 water-cooled machine gun, began work on a .50 caliber version. His first prototype fired on the 15th of October 1918, weeks before the armistice. Browning's water-cooled prototype was trialled in October 1918. The M1921 family was developed through the 1920s, entering production in the late 1920s and evolving into the M2 series by the early 1930s. After Browning's death in 1926, Dr. Samuel H. Green of the U.S. Ordnance Corps redesigned the receiver into a universal configuration capable of 7 different combat setups. This produced the M2 designation in 1933 and the definitive M2HB, heavy barrel, variant shortly after. The M2HB's specifications remain formidable. It fires the 12.7 by 99mm cartridge, commonly called .50 BMG, at a cyclic rate between 450 and 575 rounds per minute. Muzzle velocity reaches 890 meters per second, approximately 2,910 feet per second. Effective range extends to 1,800 meters, roughly 2,000 yards. The weapon weighs 38 kilograms, 84 pounds, without its tripod. Barrel length measures 1,143 millimeters, 45 inches. The operating principle, short recoil with barrel and bolt locked together, had been cycling .50 BMG rounds reliably for over 6 decades by the time Argentine defenders opened fire from Mount Longdon. In short recoil operation, the barrel and bolt recoil together for a short distance before unlocking. The barrel stops, but the bolt continues rearward, extracting and ejecting the spent case. A return spring drives the bolt forward, stripping a new round from the belt and chambering it. The bolt pushes the barrel forward into battery, locking together for the next shot. This self-regulating system automatically adjusts for varying ammunition pressures and environmental conditions. If you're finding this deep dive into British engineering interesting, consider subscribing. It takes a second, helps the channel, and means you won't miss the next one. Now let's see what happened when these ancient weapons met modern war. The L7 GPMG was not merely present in the Falklands. It was the single most important infantry weapon British forces carried. The parachute regiment sections each carried 2 GPMGs, double the standard allocation, reflecting the Para's doctrinal emphasis on firepower. Each battalion support company included a dedicated machine gun platoon equipped with GPMGs in the sustained fire role, mounted on L4 tripods with C2 optical sights, operated by 2 or 3 man crews capable of delivering accurate suppressive fire out to 1,800 meters. Goose Green taught the war's harshest lesson about machine gun support. On the 28th and 29th of May, 2 Para attacked across open, flat terrain against a force that outnumbered them. Fire support consisted of just 3 105mm guns, 2 81mm mortars, and a single frigate whose naval gun malfunctioned. GPMGs were employed at section level throughout the advance, but the lack of adequate sustained fire teams left the battalion critically short of suppressive firepower. Lieutenant Colonel H. Jones was killed charging an Argentine machine gun position. Post-action analysis identified inadequate fire support as a near-catastrophic failing. Wireless Ridge applied the correction. On the 13th and 14th of June, 2 Para's second major attack received 12 105mm guns, 12 81mm mortars, HMS Ambuscade's 4.5-inch naval gun, multiple sustained fire GPMG teams on tripods, Milan anti-tank missile posts, and Scorpion and Scimitar light tanks with coaxial GPMGs. According to Roger Field of the Blues and Royals, the scene resembled a First World War battlefield, not one of the 1980s. Constant machine gun chatter, bursting illuminants, small groups of men huddled for warmth. The result was decisive. D Company found Argentine positions already abandoned under the weight of concentrated automatic fire. Mount Longdon saw 3 Para's bloodiest night. The battalion attacked Argentine's 7th Infantry Regiment positions reinforced by Marine heavy weapons platoons. Those Marines manned several M2 HB .50 caliber machine guns. According to veteran accounts, Private Mick Southall recalled that only around 30 men of B Company and the supporting Milan and GPMG platoons remained standing after the assault, suggesting casualties of 60 to 70%. Vincent Bramley's memoir, Excursion to Hell, documents the chaotic close quarters fighting among rock formations, where GPMGs provided covering fire between positions. The battalion lost 23 killed and over 60 wounded. At Tumbledown on the 13th and 14th of June, Scots Guards veteran Les Braby described leading the support group consisting of 3 GPMGs, providing covering fire when required. When a Scorpion tank struck a mine and was disabled, Braby's GPMG group became the primary fire support element for the diversionary attack. At Two Sisters, 45 Commando Royal Marines came under devastating fire from Argentine M2HB.50 calibers. The Argentine weapons outranged the British 7.62mm GPMGs, forcing Marines silhouetted by moonlight to advance under withering suppression until Milan missiles and mortar fire neutralized the positions. The .50 caliber's Falklands story reveals a critical gap in British infantry doctrine. Britain had no standard infantry-level .50 caliber capability in 1982. The primary ground combat users of the M2HB were Argentine forces, whose marine heavy weapons platoons positioned them on Mount Longdon, Wireless Ridge, and Two Sisters. At Wireless Ridge, an Argentine .50 was documented chopping a path down the left flank of 2 Paras advance. British .50 use was improvised. The Guards battalions, Scots Guards and Welsh Guards were each allocated a platoon of Browning .50 HMGs on American-supplied anti-aircraft mounts. According to serving soldiers of the era, these weapons had been stuck in stores for a decade or two. Some were sourced from Chieftain tank stocks, where they had served as ranging guns before being stripped during the transition to laser rangefinders. The Ministry of Defence had rejected infantry establishment cases for .50 calibers on the grounds that the bullets cost too much. At sea, troops aboard the requisitioned cruise liner SS Canberra lashed .50 caliber machine guns to the ship's rails for anti-aircraft defence during the San Carlos landings on the 21st of May. When Argentine Pucara pilot Lieutenant Guillermo Crippa strafed the vessel, troops returned fire with these improvised mounts. The British .50 gap became a significant post-war lesson. Argentine heavy machine guns consistently outranged and outpunched the 7.62mm GPMG, giving defenders a firepower advantage that British forces could only overcome through manoeuvre, artillery and anti-tank missiles repurposed against bunkers. The experience contributed to wider adoption of the .50 Browning, now designated L111A1, across British infantry and vehicle platforms. According to Defence Equipment and Support, in September 2025, FN UK won a £20 million 10-year contract for mid-life improvement of the entire British L111A1 fleet. The endurance of these designs rests on physics. No fundamentally new operating principle for automatic weapons has been discovered since the early 20th century. All automatic firearms operate by blowback, recoil operation, or gas operation. Hiram Maxim invented effective machine gun mechanisms in 1884. John Browning refined recoil operation in the 1890s. Every machine gun since has been a variation on these themes. Every American program to replace the M2 has failed. The XM307, advanced crew-served weapon, was cancelled for excessive cost and complexity. The XM312 achieved only 220 to 250 rounds per minute, less than half the M2's rate, and was cancelled with Future Combat Systems in 2008. The XM806 lightweight .50 caliber offered 49% weight reduction and 60% less recoil, but was cancelled in July 2012. Funds were redirected to upgrading 54,000 existing M2s to M2A1 standard. The FN MAG was adopted by the United States as the M240 family, beginning with vehicle and coaxial rolls in 1977. Infantry variants, the M240G and M240B, were introduced to the Marines in 1991 and widely adopted by the Army during the 1990s, decades after the MAG's 1958 debut. The Americans eventually conceded that the World War II-derived Belgian design was superior to anything they had developed since. The Falklands' extreme environment, driving rain, sleet, mud, sub-zero temperatures, salt spray, favoured these robust older designs. The GPMG's gas-operated mechanism and riveted sideplate construction proved virtually impervious to field conditions. According to FN's own testing records, one MAG receiver used for production testing was still running perfectly after more than 300,000 rounds. A British L7 built in the early 1960s reportedly had close to 750,000 rounds through it. Perhaps the war's most striking feature was its technological symmetry. Argentine forces fielded the FN MAG 60-20, the identical weapon to the L7A2, the M2HB Browning .50 caliber, the FNFAL with select fire capability versus the British semi-automatic only L1A1 SLR, and the Browning high-power pistol, the same sidearm British officers carried as the L9A1. Both armies' entire small arms inventories trace back to 2 design houses, FN Herstal in Belgium and John Browning's various American manufacturers. This symmetry meant the war's decisive factors were human, not technological. British advantages lay in superior night fighting training, aggressive fire and manoeuvre doctrine, elite unit selection. Paras, Royal Marines, Gurkhas, Guards, and hard-won tactical adaptation. The transformation from Goose Green's inadequate fire support to Wireless Ridge's overwhelming concentration of sustained fire GPMGs, artillery, armour and naval gunfire proved that lessons could be learned mid-campaign. The Falklands demonstrated that weapons technology can reach a plateau of effectiveness, beyond which further innovation yields diminishing returns. The L7 GPMG and Browning M2 solved fundamental tactical problems: suppression, area denial, anti-material destruction, using operating principles that have not been improved upon because the underlying physics permits no improvement. What changed between 1945 and 1982 was metallurgy, manufacturing precision, optics, and ergonomics. What remained constant was the gas piston driving a bolt carrier through an MG42-derived feed mechanism and a short recoil action cycling .50 BMG rounds, exactly as Browning intended in 1918. Both weapons remain in frontline service worldwide today. The L7A2 serves every component of British Armed Forces. The M2, now as the L111A1 and M2A1, approaches its 108th year of continuous production. Many replacement programs have struggled, and no universally accepted replacement has displaced these designs across NATO, with life extension programs favoured over wholesale replacement. The M2's one genuine design liability by 1982 was its headspace and timing system. Because 1920s machine tools could not hold tight enough tolerances, Browning designed adjustable headspace requiring manual setting with go and no-go gauges after every barrel change. Improper adjustment risked catastrophic out-of-battery detonation. By the late 20th century, the M2 was the only adjustable headspace weapon in Western inventories. This was not resolved until the M2A1 introduced fixed headspace and timing in 2010, meaning Falklands-era crews operated under this original constraint. US comparative trials consistently showed the FN mag to be far more reliable than the M60. One test series recorded the mag achieving markedly higher mean rounds between stoppage figures, with some evaluations showing the mag outperforming the M60 by a factor of 4 or more. The M60's tendency to shed parts during sustained fire, particularly the bipod and operating rod, became a running joke among American infantry. No such criticisms attached to the mag or its British L7 derivative. This reliability advantage proved decisive in American evaluations, ultimately leading to mag adoption. More than 80 nations operate the FN mag or its variants today. The weapon has been manufactured under license in Argentina, Egypt, India, Singapore, Sweden, the United Kingdom, and the United States, with hundreds of thousands produced worldwide. The M2 Browning has been manufactured in even greater numbers, seeing service in virtually every armed conflict since the Spanish Civil War. The ancient